Okay, let me see. Let me try to. I want to see if this even works. Hold on. So we're gonna solve systems of equations again. This time I'm gonna try to do some that are more with, well, I want to continue trying to do with two systems, only because I feel as though the last time that we went, the last time that we did this, it actually wasn't, it wasn't so in depth. Give me a second, guys. So I'm gonna try to go over just how they do it and stuff, and then we'll do some practice. Actually, view online. So let's see here. Just want to make sure it's. Okay. So, so let's see here. So obviously, we're gonna go to, let's see here, maybe we're gonna go to systems of equations and inequalities. So we're gonna look at 7.1 first. So an ordered pair, by the way, is x comma y. That is an ordered pair. An ordered pair is with parentheses, and it's x comma y. That's what an ordered pair is. I'm just going over the vocabulary. A consistent system of equations, it says that it has at least one solution. So basically, if it only has one solution, it is an independent system. A consistent system can be like, it can have 2 solutions or 3 solutions, depending. So let's see. An inconsistent system is one where basically they have no solution at all. So it's 2 parallel lines. So an independent system is, and then a dependent system, it means that it has many solutions. So an independent system of equations means that it has one solution like this. Inconsistent system means that it has no solutions at all, and dependent system means that it has one solution. Okay, so determining whether the ordered pair is a solution to a system of equations. determine whether the ordered pair 5, 1 is a solution to the given systems of equations. I don't know if we did this, but we're going to go ahead and check the solution. So you see here that they basically plug it in when x equals 5 and y equals 1. They plug it in to see if it's true, and as you can see, they're both true. And here's the sketch for it. So at 5, 1 is where they intersect. So we're going to do a try it. So determine whether the ordered pair 8, 5 is a solution to the following system. So basically, we have 5x minus 4y equals 20. And then we have 2x plus 1 equals 3y. And we want to know if 8, 5 is a solution. If it is, I'm going to go ahead and graph it for y'all so that y'all know exactly how it looks. So we have 5 times 8 minus 4 times 5 equals 20. We have 40 minus 20 equals 20. 20 equals 20. So it's true. What about 2x plus 1 equals 3y? So we're going to do 2 times 8 plus 1 equals 3 times 5. So obviously, let's see here. Obviously, it's not a solution because 17 does not equal 15. So 8, 5 cannot work for that one, right? It says solve the following system of equations by graphing. So really what we're going to do, how they did it here, they solved for y on the equation 2x plus y equals -8. They solved for y, and they graphed it, right? So they solved for both, they solved for y on both. And you can see that they actually graphed it. So the red one is y equals x plus 1. The blue one is y equals -2x minus 8. So that is how they did it there. A lot of this is going to be me explaining, and then I'll do a little bit of practice afterwards. These are not my notes. I know they're from the textbook. So if you need to look at the textbook, I will post a link down below. So yeah. Let's see. So now solve the following systems by graphing. So here, what we're gonna do, let me actually, so I can actually know the maximum and minimum to put, like the scale of the graph. So we have 2x minus 5y equals -25. And then what else? We have -4x plus 5y equals 35, I think. Yeah. So I'm going to go ahead and do it all the way to -10. So let's see here. So we're gonna try to so we're gonna write them down. So we have 2x minus 5y equals -25, and then we have -4x plus 5y equals 35. Okay, so basically what we're gonna do, we're gonna grab, so let's see here, we're gonna do a graph. So we're gonna do 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, and then here's going to be the origin at 0, 0. Just quickly draw like 2 lines here. And I know, guys, this is this is annoying, but I have to do it because apparently I don't have a pre-made graph. Which is not as big of a problem, but you know, we have to make do. Okay, so, and then we have 1, 2, 3, 4, 5, 6, 7, 8, 9, oops, 10, right? So, and then we have here -1, -2, -3, -4, -5, -6, -7, -8, -9, -10, right? So this is basically the graph, and let me go ahead and just draw a graph like this. Right? And obviously up here, just gonna have, right? So then we're gonna graph the system. So this is the systems of equations that we're graphing. So basically what we're gonna do 2x minus 5y equals -25. So 2x minus 5y equals -25. I'm gonna solve my equation for y, so I'm gonna do 2x on both sides. So then this gives me -5y equals -2x minus 25, not plus. It's minus 25. And then divide both sides by -5. So then you get y equals 2/5 x minus 5, right? Or sorry, plus 5. So it should be 2/5 x plus 5. So you're going to put the y-intercept 0, 5, right? You're going to go up 2 and to the right 5. So you're going to go 1, 2, 1, 2, 3, 4, 5. Right? And then you're going to go down 2. So down 2 and to the left 1, 2, 3, 4, 5. Right here. And you're going to keep going. So let's see here. So it's going to be 1, 2, so 1, 2, 1, 2, 3, 4, 5. So right here. Okay. Once you have enough points, you can go ahead and actually trace it. And then so you're going to go 1, 2. So 1, 2, 1, 2, 3, 4, 5. Like this. So then you're going to trace it, right? So now you're just going to trace it. So it's just going to be it's like really, really hard to do it. Let me actually. So like this. This is the function y equals 2x, or 2/5 x plus 5. So that's one of them, right? The other one, we're going to do the same thing. We're going to do negative 4x plus 5y equals 35. So that's the thing, guys. You have to do it. It's kind of like you have to do it for both. So negative 4x plus 5y equals 35. And I know I'm going really slow, guys, but I really, again, like I say in all of my videos, I want to make sure that everybody understands what they're doing. So here we're going to do 4/5 x plus 7. So I'm going to do this one in pink. So this is going to be 4/5 x plus 7. So it's going to be 1, 2, 3, 4. So we're going to go down 4 and to the left 5. So 1, 2, 3, 4. And then 1, 2, 3, 4, 5. So it's going to be right here at this point, which is the intersection, right? And we're going to go again. So it's 1, 2, 3, 4. 1, 2, 3, 4, 5. So right here. Oops. Sorry. It's 1, 2. So 1, 2, 3, 4. 1, 2, 3, 4, 5. It's right here. So basically, as you can see from the graph, they actually not correlate. They actually what is it called? They actually intersect at. They actually intersect. And let me actually make sure I do this right. So this is where they intersect. And now this intersection that we have here is at negative 5, 3. So this is our solution to the systems of equations. That is how you solve it that is how you solve it by graphing. Okay. This is something that I did not go over, that I didn't really go over the last time, but this is how you do it by graphing. I feel like if I do systems of inequalities, it's a little more tricky, because you have to do, so in reality, it has to be in different colors. Systems of inequalities are trickier to graph, or to solve by graphing rather, but I will go ahead and do that for you guys. So let's see. Or actually, let's just keep going. So, so if I go down, let's see here. So let's see here. I think, let me see. I'm gonna go to systems of nonlinear equations and inequalities with two variables. Or actually, let me see. I'm not sure why they don't have systems of linear inequalities. Okay, well, yeah, I'm not sure why they don't have that. They should. So I'm gonna go to review exercises for this one. And also I will explain what they're doing. I'll do my best to explain what they're doing, and I'm gonna go ahead and, well, let's go ahead and do systems of linear equations in three variables. So in three variables, it's a lot more complex. You actually don't learn these until, I mean, you don't learn more about these until linear algebra, I believe. But in sorry guys. So basically in this class, what you're going to do is you're going to have to know how to do it by substitution and elimination. There's also Gaussian elimination, guys. I can try my best to explain it, but for me it's very difficult. So I'm not sure if I can do that. But I do know how to do by substitution and elimination. I will do my best. And we'll see how it goes. So let's see here. So let me actually go to chapter review, or exercises, so that you guys can see what I'm doing here. And guys, I don't know how to do, I mean, I barely understand matrices, so I can't promise that I'll know how to do that. Matrices are something else. So let's look at this one. Let's try to do this by substitution. Or actually, let's try to do this by elimination, okay? So 2x, so let's see here. Two x plus 3y plus 2z equals 1. And then we have negative 4x minus 6y minus 4z equals negative 2. And then we have 10x plus 15y plus 10z equals 0. So, so basically what we're going to do here, so I want to do this by substitution. So basically, we're going to get 2x plus 3y plus 2z equals 1. And let's solve for x, okay? So let's see. So we have minus 3y minus 2z on both sides. So we have 2x equals 1 minus 3y minus 2z, and divide all over 2. So we have 1 minus 3y over 2 minus z. So let this be new equation 1, right? So I'm going to grab this stuff here. Let me kind of move it down a little bit. Okay, so basically this results in 1 minus 3y over 2 minus z, right? So that's for the first equation, 1 minus 3y over 2 minus z, and then we're going to go ahead and plug this in for x in the next two equations. So we have negative 4x, so negative 4 times the quantity, 1 minus 3y over 2 minus z, minus 6y minus 4z equals negative 2. So then we have negative 4 over 2 minus 12 over 2, 12y over 2, minus 4z minus 6y minus 4z equals, sorry, plus 4z, excuse me, negative 2. So then this gives us negative 2 minus 6y. The 4z cancels out, right? Actually, it's plus 6y. And then minus 6y also cancels out, equals negative 2. So as you can see, we get negative 2 equals negative 2. What does that mean, right? That means that this system has approximately many solutions. So or it has infinitely many solutions. So the answer is this, infinitely many solutions for this system. Let's look at this one, and let's try to do this by substitution. So x plus 6y plus 3z equals 4. And guys, by the way, I do prefer elimination better, only because it's a lot simpler than substitution. X plus 6y plus 3z equals 4, 2x plus y plus 2z equals 3. And then 3x minus 2y plus z equals 0. So the first one that we have is, we're going to do it for negative 2, right? So for negative 2, I'm going to try to do this one with elimination. So I'm going to eliminate x, okay? So we're going to grab x plus 6y plus 3z equals 4, and also 2x plus y plus 2z equals 3. So then we're going to go ahead and just eliminate. So we have negative 2 here, and this is just 1. So this becomes negative 2x minus 12y minus 6z equals negative 4. Add 2x, add y, add 2z, and 3, right? You eliminate the 2x, you have negative 11y minus 4z equals negative 1. So basically, this is what we get out of these two, right? But what about the top and the bottom? So basically, now we're gonna try to do the top equation. So x plus 6y plus 3z equals 4, and then the bottom equation, 3x minus 2y plus z equals 0. So I'm going to multiply by negative 3 to get rid of my x again. So I have negative 3x minus 18y minus 9z equals negative 12, right? So then plus 3x minus 2y plus z equals 0. I'm going to go ahead and eliminate my x. I have negative 16y minus 8z equals negative 12, right? So now I have a system of two equations. Negative 11y minus 4z equals negative 1, and negative 16y minus 8z equals negative 12. So I'm going to try to eliminate my z values. So here, what I'm going to do is I'm going to multiply by negative 2, because that way it'll give me 8z and it'll cancel out. So I have negative 22, or sorry, positive 22y plus 8z equals 2, and then I have minus 16y minus 8z equals negative 12, right? So 6y equals, let's see here. I'm not sure if I did that one right. Or maybe I did. I wonder. I think I did, but I'm not sure. 6y equals negative 10. Divide by 6 on both sides, we get y equals negative 5/3. I believe that's what it is. I could be wrong, but I believe that's what it is. And then when we did so we can then do this one. So negative 16 times negative 5/3 minus 8z equals negative 12. So we have 16 times 5 is 80. And then divided by 3 minus 8, z equals negative 12. 80 divided by 3, that's, how much is that? Well, it's just 80 divided by 3. But we can subtract. So this is like saying 36 over 3 minus 80 over 3, which, give me a second, you guys. So then I end up with negative 44 over 3 equals negative 8z. So then I multiply, or sorry, I divide both sides by negative 8. And let me use my calculator. So negative 44 over 3 divided by negative 8. And that's approximately 11 over 6. So z is 11 over 6. Okay, guys, let me actually, because I need to charge my laptop. Give me a second, everybody. Okay, so I'm back. Alright, so now let's plug in y and z and solve for x. So y was what? It was negative 5/3. So we can say 3x minus 2y plus z equals 0. We have 3 times, so I think we had y and z, if I'm correct. Yeah, 3x minus 2 times negative 5/3. And then plus 11 over 6 equals 0. And if I actually use my calculator here, so let's see here. We have negative 2 times negative 5 over 3. This is 3x plus 10. Oops, sorry guys. 3x plus 10/3 plus 11 over 6. So this should be 31 over 6. So 3x plus 31 over 6 equals 0. And then we multiply the whole thing by 6. So you have 18x plus 31 equals 0. Divide both sides, or subtract both sides by 31. Get negative 31 equals 18x. Divide by 18. And we get that x equals negative 31 over 18. I'm not sure if I did this one right, guys. The thing is, these are really tedious. I'm pretty sure I am doing it very slowly. I'm trying my best to do it as slowly as possible. But I can make mistakes. Yeah, so, but anyways, I can't do Gaussian elimination. That's the only thing I cannot do is Gaussian elimination. But I might do another stream over other things. So like, radicals and rational exponents. I will make a video over that. Equations and inequalities, polynomial and rational functions, exponential and logarithmic functions, basically systems of equations and inequalities. All you really have to know is substitution, elimination, and maybe Gaussian elimination. I'm assuming you might have to know like matrices and inverses, but I am not completely sure about that. Those are things that I just can't do. But I can do exponential equations, polynomial, linear functions, rational functions, radical functions, etc. So with that being said, guys, I am going to end it here. I can also do analytic geometry, and, you know, and that other stuff, right? All this other stuff right here. I'm going to end it here, though, guys. Please let me know what you think. Please like, comment, and or subscribe. And for whoever watches, thank you so much for watching, and I will see you guys